Welcome to the concept of energy perspective of process utilities. So before we go into the detail of this energy perspective, let's have a look about a brief that what we discussed in the previous lecture. We had a brief introduction about the subject in which we emphasized that what is the concept of chemical process utility, why it is so important. Then we had discussed about the electricity approach or electricity utility requirement with small examples. And then we studied about the concept of heating units, in which we analyzed that how we can give a major importance to the load of any heating unit, because you all understand that we cannot overlook the importance of this electricity requirement or a heating unit requirement in due course of time. Now, in this particular chapter, we are going to discuss about the energy perspective of steam. Remember, this is an introductory aspect, and energy perspective of hot oil. Now, as we understand that steam is widely used in various industries for heating purpose when moderately high temperature is required. Now, when we talk about the moderately high temperature, again it is attributed, and there are so many parameters associated with this particular high temperature, moderately high temperature concept. It also depends on the pressure aspect. It also depends on the various other allied units like steam traps, condensers, etc., and the steam distribution network, because sometimes the pressure may get dropped during the course of steam transportation or steam distribution. So the question arises that what are the advantages associated with the steam? See, steam is having a plus point as well as there are certain negative point, and above all there are certain limitations associated with the steam. So let us take some of the advantage of steam, because we are discussing the steam. Now, being the pressure dependent, the temperature of the steam can be precisely controlled for heating operation. Your regular thermodynamics law always prevails in this condition. So sometimes this is a beneficial condition and sometimes it is a disadvantageous condition. We will discuss this aspect during the study of steam in detail. Then compared to other utilities like heating oil, flue gases, steam has a high heat output per unit mass because of the latent heat aspect of water. Now, this is due to its, again you can say another diplomatic word, that due to its high heat of condensation. Another thing is that the other advantage is that for heat transfer application, steam provide a high transfer coefficient which enhances the efficiency of the operation. So, again this is the purely heat transfer phenomenon. Above all, it does not harm, clog or choke the engineered heating system, which leads to the low maintenance cost. Other advantages like it's non-flammable, non-toxic, because your basic raw material for generation of steam is water, which is invariably a non-toxic substance. Now, you can easily determine or you can easily visualize that if any system leaks, because the vapors may come out from that particular segment. So, you can easily determine that where is the leaking, where is the problem, which function is malfunctioning. Steam generation is a well researched field, and system and workforce requirement can be easily handled. We always talk about the steam table, etc., during our initial days. So it is a very research. Everybody knows that what is the integral part of steam, how we can control, what is the latent heat, what is the pressure and temperature relationship, etc. So steam is well researched, well studied. Now, as I told you that we will have a detailed discussion of steam generation, steam control, steam distribution, again the condensation, steam traps, safety devices, etc., in the upcoming lectures. Now, unlike power plants, industrial units are open, meaning that most of the steam remain unrecovered and the condensate sites. Now this gives rise to the to produce more makeup water, which is again a costlier process. Now this particular segment means a lot. See, before we go into the detail, what are the integral part you require for the steam generation? Steam generation, you require some source of heat. Steam generation, you require adequate supply of water. But you cannot use water as such, because sometimes water may have some hardness, sometimes may have certain ions, sometimes may have different type of impurities, debris, etc. So before using this water as a steam producer or in a boiler segment, you need to purify it. Purification or conditioning may be with the help of deionization, demineralization, screening, etc. So it costs, because all these unit operation, again they are costly affair. So once you utilize the steam being generated from the boiler to the particular point, in that case, after when the steam use is over, the steam may get condensed to give the water. Now again, there are two main losses are may be attributed. One is that loss of energy during the condensation with respect to the latent heat, or second is the loss of water. Remember, while generating the steam, you have contributed a lot of capital expenditure with respect to the water conditioning. So this, the condensed water, is again can be utilized to in the same steam cycle. So you need to give a proper attention to all these aspects. Otherwise, you may require to consume or to produce more makeup water, and it will be a costlier affair, and again it will ultimately contribute to your product cost. So while considering, because see in chemical engineering we are having wide spectrum of industries. So every industry has their own guidelines to distribute, categorize the steam. Now broadly we can classify into three different forms. One is the high pressure steam, which is nearly 40 bar, condensate temperature usually 250 degrees Celsius. Then medium pressure steam 20 bar, and the condensate temperature is nearly 212 degrees Celsius. And the low pressure steam, that is 3 bar, and the condensate temperature is 130 degrees Celsius nearly. Now again we can classify steam in a different other microscopic level, but these are the broad classification. Now based on this classification, you can design your own steam generation system, that how much requirement is there on the site. You may design your own distribution network. Even you can adopt the policy of a centralized boiler system to produce the steam, or discrete type of water steam generation system at the place of work. Now again come back to the classification, that steam having the pressure higher than 40 bar, it can be achieved using the demineralized water as a feed. But the latent heat recovery from such type of system is a very high pressure steam is practically not feasible. So while designing the distribution network or a usable network, you have to look into this particular aspect, that every time you say that the recovery, heat recovery is a very catchy term, but you have to look in the engineering aspect that whether it is economical or not. Now high pressure steam system utilize soft water instead of demineralized water and have enough pressure to drive a reasonable sized turbine. Now some literature, they may consider the steam having the pressure higher than 100 bar, say 140 to 2 or 206 bar as a high pressure steam, while steam having the pressure near to 40 bar is termed as reheat or IP steam, etc. So all depends, I told you that there are a broad classification scheme for steam classification. So in all case the steam having a pressure near to say 40 bar is considered reasonable, and effective for heating and a cost recovery purpose. Now here the steam at say 40 bar pressure is defined as high pressure steam. Now this high pressure steam is utilized for process heating and for moderately long distance transportation. Now remember, when we talk about the long distance transportation system, then you have to look the pressure drop. This may occur because of the condensation, because of a variety of reasons. Medium pressure steam is used for intermediate heating and usually considered effective for heat recovery from the plant using the pinch technology. We will discuss this aspect later on. Now the cost of producing high pressure steam, it can be calculated by counting the cost of preparing makeup water, water softening, price of fuel and a boiler efficiency. See again the rule of thumb is that you cannot make a system 100% efficient. So this is a simple mathematical formula. It gives you an idea that what should be the cost of high pressure steam. So cost of high pressure steam, this is equal to the cost of fuel, heating rate, then the boiler efficiency. So boiler efficiency is again a very you can say important affair. Then cost of boiler feed water. I told you that boiler feed water, again it is a very costly affair to condition the water as per the desired level. Now if condensate is returned to the boiler feed water, then the estimation of cost of steam should be claimed for the condensate. Now let us take that say for 100% recovery, the cost of boiling feed water can be compensated with the credit from the condensate, hence it can be neglected during the further calculation. So the cost of medium pressure and a low pressure steam can be calculated by discounting the earning from the shaft work produced by the steam work. Now alternatively, the cost of steam can be approximated as CF plus 0.3 into CF, where CF is equal to AF, that is the fuel cost in Indian currency. Then HS is the enthalpy of steam in BTU oblique on. Now enthalpy of the boiler feed water. Now see, we have given couple of mathematical relations. So let us take an example. Now you need to calculate the cost if a boiler is producing steam at the rate of 10 tons per hour with the fuel cost of say 130 rupees per MMBTU. Enthalpy of steam and water at 6 bar and 158.8 degrees Celsius, it is 2756.14 kilojoule per kilogram and 670.5 kilojoule per kilogram respectively, and you may take the boiler efficiency as 0.88. So go back to this particular formula. CF is equal to AF into HS minus HW upon 1000 into the boiler efficiency. Now we know that 1 kilojoule per kilogram is equal to 0.43 BTU per pound. Now here we know that this is AF is 350 rupees per MMBTU. So 350 multiplied by 2756.14 minus 670.5 in. Now see, it is that 1 kilojoule per kilogram is equal to 0.43 BTU. So it should be multiplied by 0.43 divided by 1000 into the boiler efficiency, which is given in the problem is 0.88. So it comes out to be 356.68 rupees per kilogram. Now CHP is equal to 1.3 into 356. It comes out to be 463.69 rupees per kilogram. So, we can calculate the annual cost by considering the generation of 8,000 hours per year. Now, roughly this is the rough estimate of 8,000 hours that boiler works in usually 8,000 hours per year. So, the total steam generated is 8,000 hours per year multiplied by 10 ton usually require is 80,000 tons per year, and if we multiply it by 907.18 kilogram per year. So, the total cost of per year would be 80,000 907.18 into 463.69, it comes out to be 3.36 to 10 to the power 10 rupees per year. Now, let us take another example of hot oil. Now, again hot oil is a very good heat transfer media. So, when multiple moderate temperature heating is required in a particular system, it is economical to have a hot oil in the process. This is sometimes termed as I told you that heat transfer media or heat transfer fluid. They are generally consist of mineral oil or any other high heat capacity fluid. So, nowadays we are having a very because of the technological advancement, we are having a very big basket of this hot oil. So, we are having ample of choices. We will discuss this particular thing in due course of time in the subsequent lectures, that what are the prerequisite for any mineral oil to be used as a heat transfer media or heat transfer fluid. So, hot oils, they are usually works at usually within the temperature range of 50 degrees Celsius to 400 degrees Celsius. Now, you see somebody may ask that why we are not using steam, because steam is water is available in abundance. See, if we go beyond 250 degrees Celsius with the steam system, then it creates a lot of problem and a lot of working or capital be needed for this type of steam generation, and that is why hot oil they offers a very good choice or economical choice. Now, these hot oils can be heated to higher temperature depending upon the thermal decomposition and falling characteristics of fluid. So, these oils are having their limitations with respect to the composition, with respect to its formula, molecular weight, etc. And sometimes they may get decomposed to give some low heat products, and it may be a very dangerous affair if we are not using the suitable heat transfer media. For multi-point heating application, it is not feasible to incorporate the multiple fired heater. It is sometimes uneconomical. Therefore, these hot oils are circulated throughout the system while using the single large sized fire heater for heating the fluid, keeping in view of all the limitations associated with these hot oils. Now, it is practically better to avoid the vaporization of mineral oil. So, there are certain limiting factor with respect to the temperature and pressure. So, if we are violating those conditions, then it can start decomposition, and less volatile component, as I discussed, they can accumulate on the walls of a reactor, resulting the accelerated falling, and sometimes it may create a problem, or sometimes it can pose a safety hazard. Now, these hot oils, these can be heated to a higher temperature at a low pressure limit. Now, this feature lead to the selection of tubes with a lower thickness, which reduces the cost of instrument as well as it reduces the cost of operation or working cost. Now, as compared to the fired heater, the use of hot oil, say they are relatively safe, as there is a minimal chances for tube to get exposed to high wall temperature. So, these are some of the advantages associated with this one. Apart from this, the cost of operation is usually equal to the cost of oil plus the cost of heating. So, by this way sometimes if you are not having any kind of a chance of a leakage or any other thing, then you can minimize the cost. Now, in a longer run, the cost of mineral oil can be neglected as the major cost is related to the cost of heating the oil. But simultaneously, you cannot overlook the fact that this mineral oil is being repeatedly used, and sometimes if any kind of unsaturation is there, it may get polymerized. So, you need to find out that up to how many cyclic operation you can carry out with the simple single set of mineral oil. Now, if a pumped liquid heating system is utilized, then the operating cost of pump should also be included in the overall cost. So, ultimately it contributes towards the cost of utility. So, the cost of heating using fired heater is we have already discussed in the previous lecture. So, by this we are coming to the end of this particular lecture, and again if you are looking for some more detailed knowledge about this particular segment, you can have a look up this reference. Thank you very much.